What's a graviton? A graviton is the particle that would correspond to the gravitational force, in the same way that the photon corresponds to the electromagnetic force. How is it possible for a force to have a particle associated with it? Well, remember, it comes back to that weird quantum mechanical picture where you can have something that acts like a wave sometimes and something that acts like a particle at others. And also, it has to do with the field nature of nature at fundamental levels. Now, the interesting thing is, if it exists, we would expect it to be a spin 2 boson. A spin 2 because the stress energy tensor, which it corresponds to classically, is a rank 2 tensor. So it's like a vector, except it has an additional direction, an additional degree of freedom. And we would expect it to be a boson because, like other force carriers, it can pile up all into one state. How could a black hole turn you into a graviton or a bunch of gravitons? Well, as you fell into the black hole, you would be crushed, and you would be crushed into such a small volume that all the forces, the Pauli exclusion forces, like the Fermi degeneracy pressure, the electron degeneracy pressure, and the neutron degeneracy pressure, to be specific, because there's two forms, they would be overwhelmed. And so all your mass energy would suddenly be able to pile up into a single state. You would no longer be composed out of fermions. You would be made out of bosons now. And bosons can all pile up into the single state. So you could be crushed into a state that's just basically a point in space and time, and it would be a particle like gravitons, and it wouldn't violate either theory. How could gravity be a curvature of space and time, but also a particle? I mean, we hear that in general relativity, gravity isn't even really a force. It's just a curvature in space and time that looks like a force to us. But then it might also be a particle? How is that possible? Because in quantum field theory, we quantize space and time itself. So actually, these curvatures of space and time could be acting like particles because they could be quantized bits. Now, quantizing space and time is necessary even to get the correct results of quantum electrodynamics, which has been experimentally tested to a very high accuracy. So it's possible to do this. However, there are challenges, which I'll talk about in future videos. A lot of people are confused about gravity. Is it a force or not? Einstein says it's not a force, that it just emerges from space and time being curved. But then we talk about these force particles called gravitons. Which is it? Well, it's important to understand that in Einstein's theory, he thought that electromagnetism would also emerge from the underlying background of space and time. And on his dying day, he died trying to unify electricity and magnetism with gravity, but he was unsuccessful. And he didn't really know about the weak nuclear force, and he didn't know about the strong nuclear force at all. So the situation since Einstein's day has changed. Quantum field theory has completely changed our concept of what forces and particles could be. Stay tuned for more. We've heard that gravity isn't really a force like the other forces, that it just emerges. But then you just found out that Einstein was trying to turn all the other forces that he knew about into emergent forces as well. So what is it then? Well, the secret is that we need a better understanding of quantum mechanics. We need a better understanding of how the underlying space and time curves and how this curvature impacts the way that matter and space and time itself is structured. Yes, it is still possible that all of the underlying forces could be unified, and they might all be different manifestations of the way that space and time curves. Electricity and magnetism, for example, might be some type of special way that space and time is curving in that case. Same thing for the strong and weak nuclear forces, but there's work to be done, and it has to be unified with what we know about quantum mechanics and general relativity.